Good morning, everybody. Welcome to a wonderful Tuesday morning at Chem 1211 with your host, me, Dr. White. All right, let me remind you that there's a new login for our Zoom meeting. My old one disappeared. I don't know if I forgot to extend it long enough or something weird happened. But anyways, the new login data is now on Blackboard. You also got an email. Also, let me remind you that next week, from Monday through Thursday, you will be taking test number 1 at the COD testing center. You'll need a photo ID, and I highly recommend you bring your own calculator because you know how to use it. I don't know how good the ones they have there. I really don't. They could be very good or not. But if they're not the ones you're used to, that could cause you some problem. Also, if you are a special needs student, make sure you bring either a screenshot on your cell phone of your letter from the Center of Access and Accountability, or you bring a printout of that letter. That way, they'll give you whatever special needs you have. All right, let's see. Anything else I should talk? Oh, yes. Uh, Yesterday, I talked about the email I'd sent out about if you didn't see a lab score. A couple of you have already replied. I should have that taken care of by this Sunday at the latest. Catching up this week, I'm busy with other things too. All right, what I said I would do today is go through Chapter 7 problem set, Chapter 8 problem set, and the lab. And the lab, remember I said yesterday, I switched 2 labs. I like that special effects. Switched 2 labs. And today we'll do balancing chemical equations, which means we're going to get out early today. Yay. Even though if I have to stay late, I will, because you guys are worth it. All right. All right, thumbs up, people. And let me first make this a little smaller. Everybody see Chapter 7? Thank you. Now, how do you balance an equation? You make sure you have the same number of elements of each element on both sides of the arrow. And remember, at the base of the arrow, those are the reactants or starting materials. At the head of the arrow, those are the product or products. Again, base of the arrow, reactants, and I'll also use the term starting material. Head of the arrow, reactant, product. Hold on, I got to reboot. All right, base of the arrow, reactants. Head of the arrow, products. So if we look at number 1, how do we balance it? Well, forget about the numbers in front, because they wouldn't be there. In fact, let's go to the whiteboard for this one. And on test number 1, I think there are 3 or 4, I'll have to check, balanced chemical equation questions. And when I put it on my test, you will always have to balance it. The answer, it's already balanced, will never be correct. Now, if we look here, we have 2 chlorine. Remember 2 here. And here we have 1. Well, we need 2 on each side. You can't change the formula. Students try and do that, but you can change the coefficient. So now they're 2 chlorine, but now 2 times 1, 2 sodium. Well, over here, I only have 1. So how do I get to change the coefficient, the number in front? And now I have 2 sodium. And something I like to do, first of all, is underneath when I'm balancing chemical equations, write how many on each side. Remember, this is the reactants. at the base of the arrow, and the product or products are at the head of the arrow. And now, because I took the time to write these out, I can say I have 2 sodium here, 2 sodium here, 2 chlorine here, 2 chlorine here. I'm balanced. So I'm done. And that's how you balance equations. Now let's look at another one. And here for number 2, a couple of things. First of all, I had lithium, that should be aluminum. And let me find something. And let's go to the whiteboard. All right, now, if you notice, I have 2 aluminum here. I don't have 2 there. But before I change anything, I'm going to look at something that sticks out like a sore thumb. Well, mine isn't sore, but anyways, here I have 2 oxygen. Here I have 3 oxygen. And this is what I call even, odd balancing equation, an even odd situation. There's no way I can put a number up here and multiply it by 2 and get the number 3. There's no way I can put a number here, whole number. Remember, the coefficients are exact whole numbers, and multiply it times 3 to get the number 2. Well, what do? Well, the easiest way, and I call it a trick, but a procedure is, what's the simplest number that both 3 and 2, or 2 and 3, go into? And the answer is 6. 2 times 3. To get 6 oxygen on this side, I multiply that by 3. To get 6 oxygen on this side, I multiply that times 2. So I now have the oxygen balance. But now if we look at aluminum, 2 times 2, there's 4 aluminum. But not on this side, there's only 1. So how do I get it to 4? I change the coefficient. 4 times 1, 4 aluminum. And now I'll check. 4 aluminum, 6 oxygen, 6 oxygen. This is now balanced. Now, one thing I've neglected to talk about, and let's do another reaction. And here I have 2 oxygen. To get 2 oxygen here, put a 2 there, 2 oxygen. And now I have 2 times 2, 4 hydrogen. How do I get 4 hydrogen on this side? Well, put a 2 there. And now 4 hydrogen, 2 oxygen, 2, it's balanced. Now, what I want to point out, and this is important, this technically well, in fact, has the same number of elements and atoms and type and number on each side. 4 times 2, 8 hydrogen. 2 times 2, 4 oxygen. 4 times 2, 8 hydrogen. 4 times 1, 4 oxygen. However, this is, hold on, let's go special effects. Wrong. Even says it on the screen. Oh, that was bad. Why is this wrong? If you have a equation and you can divide all the coefficients by the same number and get a whole number, then you have to do that. Because in a balanced chemical equation, if you've done it correctly, you cannot divide all the coefficients by the same number and each afterward get a whole number. But notice if I divide this by 2, this by 2, this by 2, this now becomes 2, 1, 2, which is what the correct one is. So if you can divide all the coefficients by the same number, get whole numbers, you have to do that till you can't anymore. And then that's the correct balanced equation. All right, let's look at number 6, because this illustrates another thing that you should be familiar with. And this is called combustion, where you burn something with oxygen. Now, what I want to talk about is my pro tip. And my pro tip is when you're balancing chemical equation and you have more than hydrogen and oxygen, leave those two for last. So let me do that. Up here, oh, 5 carbon. How do I, oh, this only has 1 carbon. How do I get 5 carbon? I can't put a 5 there. Students try and do that, but I can change the coefficient. So now I have 5 times 1, 5 carbon. I'm going this way, and notice now all I have left is hydrogen and oxygen. So I have 12 hydrogen. Well, I only have 2 here. How do I get that to 12? I can't change that 2, but I can change the coefficient. 6 times 2, 12 hydrogen. Now here I have 2 oxygen. How many oxygen on this side? We have to look at all the molecules. 5 times 2 is 10 oxygen. Plus 6 times 1 is 6 oxygen. Add them together, and on the product side, that's the one on the right, we have 16 oxygen, if I did all my math right, which I did. Well, how do we get this side to 16 oxygen? Put an 8 in front. 8 times 2, 16 oxygen. And now I look at that and say, is it balanced? And here's how you check. Took the time to write this out. I have 5 carbon, 5 carbon. I have 12 hydrogen. Ooh, I have 12 hydrogen and 16 oxygen, 16 oxygen, success. It's balanced. Now let's try one more. And I got to copy it down correctly so I can transfer it. And let me just check something real quick. And I've checked real quick. Now, I'm going to let you have some fun. Why don't you try balancing this? Leave hydrogen and oxygen last. Your turn. And when you're done, give me a thumbs up. All right, my turn. Now, I'm going to follow my pro tip, which is leave hydrogen and oxygen for last. So if I start this way, I have one iron. Oh, I have two iron here. Fe is iron. So how do I get two? Put a two there. So now I have two iron. Next, oxygen, hydrogen. Now wait, hydrogen. Oh, sulfur. I have one sulfur here, but remember when it's in a bracket, 1 times 3 means there's 3 sulfur. So how do I get 3 sulfur on this side? Put a 3 there. So I now have 3 sulfur. And if I look at that, all I have left is hydrogen, oxygen. So I'm going to do hydrogen first. You could do oxygen first too, it doesn't matter. And notice I have 2 times 3 times 1. 1 inside the bracket, there's 3 here, but there's 2. So that means there's 6 hydrogen there. And then 3 times 2 plus 6 hydrogen, the other molecule. And that adds up to 12 hydrogen. On this side, well, there's no hydrogen there, but there's 2 here. How do I get that to 12? Well, you can't change the 2, but you can change the coefficient. 6 times 2, 12 hydrogen. Now come on this side, how many oxygen? Because that's all that's left. Again, it's in the bracket where there's a 3, but in the front here 2, so 2 times 3 times 1, 6 oxygen. But over here, 3 times 4 is 12 oxygen. And that adds up to 18 oxygen. Now we come on this side and notice there's a 4 inside the bracket, which you multiply by the number subscript to the right outside the bracket. That's this right there. 4 times 3 is 12 oxygen. Then here, 6 times 1 is 6 oxygen. Add those together and you get 18 oxygen. And now I think I'm done, but I'm going to check. I have 2 iron, 3 sulfur. Ooh, looking good. 12 hydrogen. Ooh, really looking good. 12 hydrogen. And finally, yes, 18 oxygen, 18 oxygen, success. That's balanced. So that's how you balance chemical equations. Let me remind you, practice. Do the practice problems, and also the lab today will give you more practice problems. And remember my 2 tips, how to do even and odd, and then also the other one, leave hydrogen, oxygen for last. And that makes your life real easier. You don't have to, but it makes it quicker and easier to balance a chemical equation. Any questions on balanced chemical equations? All right. Well, in that case, let's move on to Chapter 8, Problems. Now, let me open up something first, which I didn't. All right, got things open up. All right. Well, that's not what I wanted. Oh, all right, everybody see Chapter 8 practice problems on your screen? All right. Now, let's look at problem number 1. Problem number 1 says for the following reaction, and you're given a balanced chemical equation, C3H8 is propane, that's the stuff in the white tanks for your barbecue, reacts with 5 moles or molecules of oxygen to make 3 molecules of carbon dioxide and 4 molecules of water. Now, the question is, how many moles of oxygen are needed to make 23.33 moles of CO2? So here we have, what are we being asked to find? And I like to use the question mark, moles of oxygen. What are we given? The moles of CO2, but we're also given the balanced chemical equation. Now, if we start with the only number we have to start with, 23.33 moles of CO2, we now, what units do we want our answer in? Moles of O2. And now if we had a ratio, convert moles of CO2 to moles of O2, how would we find that ratio? You use your good buddy, your good friend, unit analysis. And it has been my good buddy, good friend, and many of my former students, and hopefully you too. Whatever you're trying to get to goes on top of the ratio, moles of oxygen. Whatever you're trying to get rid of goes underneath the ratio. On the bottom, moles of CO2. Where do we get these numbers? From the balanced chemical equation. The coefficient, the number in front, tells you how many moles relationship. When there's no number, it's the number 1. And here we have 1 mole of C3H8 reacts with 5 moles of oxygen. Remember, the coefficient is moles to make 3 moles of CO2 and 4 moles of water. Now we need the relationship between moles of CO2, moles of oxygen. And for every 5 moles of oxygen, that's where we got the 5, we use 3 moles of CO2. And that's where we got the 3. These are exact numbers. Therefore, since this number is 4 significant figures, I made a mistake. This should be 4 significant. Don't look, don't look. Dr. White lost his perfect score. But anyways, that's how you do it. All right, let's have you try one. All right, let's take a look at this problem. How many moles of ammonia are needed to make 4.58 moles of nitrogen? All right, right here, your turn first. What are you being asked to find? What are you given? And when you figure that out and done, just that first part, give me a thumbs up. All right. So we're being asked to find how many moles of ammonia. What are we given? This number. And we're also given the balanced chemical equation. So how do I begin? Well, I only have one number to work with, so I will. And if I had a conversion ratio, what units do I want my answer in? Your turn. That's all I want you to do. Okay. Well, you figured that out up here. Moles of ammonia. And we'll do this stepwise. What units go on top and bottom of that ratio? Your turn, not the numbers, this the units. Use your good buddy, your good friend. Again, this the units, what goes on top and what goes underneath that ratio. All right, my turn. And like I said, use your good buddy, your good friend unit analysis. Whatever we're trying to get to goes on top the units. Whatever we're trying to get rid of goes underneath. And now I'll take the time to write that in. And where do I find a relationship between moles of ammonia and moles of nitrogen? And let me fix this up. That's better. And where do we find these numbers? Your turn, and then I'll do it. All right. We find those numbers from the balanced chemical equation that you're given. And the coefficients, the number in front, gives you molar relationships. So what it says here, for every 4 moles of ammonia, we make 2 moles of nitrogen. Again, for every 4 moles of ammonia, that's where I got the 4, we make 2 moles of nitrogen. And that's where I got to 2. So now before I pick up my calculator, notice moles of nitrogen divided by moles of nitrogen. Anything divided by itself equals the number 1 because it cancels out. And I'm left with the units I want. Now remember, coefficients are exact numbers. So for this problem, for this calculation, which is a multiplication division, you get the same number of significant figures in your answer as the number of significant figures in your multiplication division that has the fewest significant figures. And that's 3 significant figures. All non-zero numbers are significant. These are exact numbers. They don't play a role. So my answer should have 3 significant figures. And now I'll turn on my calculator, clear it, 4.58 times 4 divided by 2. And it turned out my calculator gives me 3 significant figures, 9.16. And that's how you do that. Remember, the coefficients in front of a balanced chemical equation give you molar relationships. I don't put that important information that you have to remember. And now let's look at number 6. Number 6 is for the following reaction, and I give you a balanced chemical reaction when you, how many grams of CO2 are made when you react 45.66 grams of C3H8 propane with an excess of O2 oxygen. Whenever you see the term excess of a chemical, ignore it. So the question is, what are we being asked to find? Grams of carbon dioxide, CO2. What are we given? 45.66 grams of C3H8, propane. Now, when you're given a balanced chemical equation and you're going to go from grams to grams, which is mass, you need 3 steps. And if you look at important information, test number 1, this is in the lecture section of Blackboard, you'll see right here, mass, which is gram calculation for reactions. Step 1, whatever you give them the mass of, we'll call it A for now, you convert that to moles of A, which we did yesterday, we practiced. Next, convert the moles of A to moles of B. Well, we just practiced that, and you'll see. And finally, convert moles of B to mass, which is grams of B, which we practiced yesterday. So let's see how we do this problem. All right, so the first step, we're going to go from grams of C3H8 to moles of C3H8. And how do we do that? Use your good buddy, your good friend, unit analysis. Whatever we're trying to get to, put on top of the ratio. Whatever we're trying to get rid of goes underneath the ratio. And where do we get a relationship between a mole of a compound, in this case C3H8 propane, and the weight of propane? You go to, in case you forgot, important information. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights in grams. Remember, on test 1, it will say underneath your name, please use proper significant figures for all calculated answers, and it will also say, please use 3 significant figures for all atomic masses. And we practiced that yesterday. So what's the molecular weight of propane, C3H8, 3 carbons, 8 hydrogen? Each carbon is 12.0. Each hydrogen is 1.01. Do the multiplication, add it up, and you get 44.08. Now, don't forget, you have the same number of significant figures to the right of the decimal. I think that's going to my right, to the right, as the number that has the fewest. Notice 36.0, one number past the decimal, 8.08082. So 1 is the lowest number. So you have to round 44.08 to 1 past the decimal. Keep the 0. Use the 8 to round off. And is that 4 or less, or 5 or higher? And hopefully all pick 5 or higher. You drop that, increase the 0 by 1. So that's 44.1 goes in here. Notice grams of propane divided by grams of propane cancel out. We're left with moles of propane, C3H8. 4 significant, 3. The 1 is exact number. My answer here is 3. Now, these multi-step, you can round off at each step, which I'm a round off at each step person, or you can wait till the end. I will calculate it both ways, and sometimes they're the same, sometimes they're different. So, are we done? No, we're trying to get the grams of CO2. So, what should we be doing? We now do step 2, convert moles of A to moles of B. So we just figured out in step 2 here, we're going to take the moles of C3H8 and convert to the moles of our answer, CO2. Here, again, having a ratio, use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. Where do we get these numbers? From the balanced chemical equation. What's the molar relationship between C3H8 and CO2? Remember, when there's no coefficient visible, it's the number 1. I like those special effects. But anyways, 1 mole of C3H8 makes 3 moles of CO2, because the coefficient in front of CO2 is 3. So for every 1 mole of C3H8, we make 3 moles of CO2, carbon dioxide. Notice moles of C3H8 divided by moles CH3H8 cancel out, and we're left with moles of CO2, which we want. 3 and 1 are exact numbers. The 1.04 is 3 significant, and my answer is 3 significant numbers. Are we done? No, we have moles of CO2. We want grams of CO2. Well, what do? We do step 3, moles of whatever we figured out to mass grams of what we need to find. So we have moles of CO2. We want to get the grams of CO2. How do we proceed? We have a ratio to convert moles of CO2 to grams of CO2. How do we do that? Use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top of the ratio. whatever we're trying to get rid of goes underneath. Where do we get a relationship between mole of a compound and grams of a compound? From important information, test number 1, which will be the last 2 pages of your test when you take it next week. And here, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. So if we go back here, we have right here moles of CO2. We want to go to grams of CO2. Unit analysis, grams go on top of CO2, moles go underneath. 1 mole of a compound equals the molecular weight. And I have it on both sides. I wonder why I did that. It's in stereo. But there's 1 carbon, 2 oxygen. I don't have it here. Each oxygen is 16.0. 16.0 times 2 is 32.0. 1 times 12.0 is 12.0. Add it together, you get 44.0. Notice both numbers have 1 number to the right of the decimal, and my answer does too, so I can use that. Moles of CO2 divided by moles of CO2 cancel out, and you're left with grams of CO2. This is 3 significant, 3 exact number. 137 is the answer. Now, you could also have 1.37 times 10 to the first. That's just converting 137 into scientific notation. Now, notice I have there both ways. What that means is you round off at each step or round off at the very end, you get the same number. Now, if you look at other problems, like number 5, the very answer at the bottom, 7.53 times 10 to the third, notice I have or, hopefully you can read cursive, 7.50 times 10 to the third grams. And that's where the difference between rounding off at each step, which I'm a round off at each step person, or round off at the end. And I will not take off points if you round off at the end person. But either way, you got to do it right. All right. Now, I'm going to do something different. Usually we'll take a break around now in a couple of minutes. We're going to go through, because I'm going to let you out early today, because we'll finish early. Let's look at one more problem. All right. Now, does everybody see number 8 on your screen? Thank you. Now, for the following chemical reaction or following reaction, how many moles of water are made when you react 4.12 moles of C3H8 propane with 18.4 moles of O2? Now, what are you being asked to find? Moles of water. What are you given? The moles of C3H8 and the moles of O2. Now, remember, at the base of the arrow, those are the reactants. And whenever you're given a problem where you're trying to find moles of a product, which water is, and you're given both moles of the reactants, this is this type of problem. If you look at important information, test number 1 says limiting reactants. And here, determine the number of moles of product produced using moles of each reactant. And the lower number is the answer. So first we have to do 2 steps, find the moles of product produced from each reactant, and then determine which is the lower number, and that's the answer. So First one, I want to go from moles of C3H8 to moles of water. The reactant we're being asked, the product we're being asked to find. So I use this ratio, use my good buddy, my good friend, unit analysis, moles of water goes on top. What I'm trying to get rid of goes underneath. And where do I get a relationship between moles of C3H8 and moles of water? From the balanced chemical equation. The coefficient, and if you don't see anything, it's the number 1. And 1 mole of C3H8 makes 4 moles of water. Again, the coefficients are molar relationships. And 1 mole of C3H8 makes 4 moles of water. These are exact numbers. This is 3 significant figures. Here's my answer to 3 significant figures. And now we go to the other reactant, oxygen. We have 18.4 moles of oxygen. We want to go to moles of water, use unit analysis again. Moles of water go on top of the ratio. Moles of O2 go on the bottom. And where do we get these numbers to put in a ratio? From the balanced chemical equation. The coefficient tells you molar amount. And here, 5 moles of oxygen make 4 moles of water. Again, the coefficient, molar quantity. 5 moles of oxygen make 4 moles of water. And that's where I got these numbers. This is 3 significant, well, first of all, moles of oxygen divided by moles of oxygen cancel out because anything divided by itself is the number 1. Ooh, I'm hooked on this. Stop. But anyways, so I do the math. These are both exact numbers, 4 and 5. This is 3 significant. We get 14.7 moles of water. Now we're being asked to find how many moles of water. And you look at step 1 and 2, whichever is the lower number is the correct answer. And it even says there, answer is the lower number of steps 1 and 2. Wow, whoever wrote these up is really thorough. Thank you, Dr. White. You're welcome. Now I'm off my ego trip. All right, and that's how you do these. Any questions on those types of problems?
I just have a question about chapter number 5, because I don't think so we have any practice problems. I don't remember.
What's chapter number 5 deal with?
Yeah, I don't remember. I just saw it on the announcements that you said
Look,
5 to 10.
I know. All right, let's take a look. All right, chapter 5 talks about types of chemical bonds, and all right, do you see it right now on your screen?
Yeah.
All right, so it talks about the chemical formula, which we already talked about. There's 2 types of chemical compounds, ionic and covalent. I talked about a molecule, which I'm not going to ask you on a test what's a molecule. We talked about chemical bond. I'm not going to ask you that. Now, there are 2 types of bonds, ionic and covalent, and you should know the definition. So I could have asked a question, what's an ionic bond? And that's the transfer of 1 or more electrons from one atom or group of atoms to another atom or group of atoms. And then what's a covalent bond? And I could ask on test number 1, what is a covalent bond? 3 points each. And that's the sharing of 1 or more pairs of electrons between atoms. Okay? And I talked a little, and I won't have anything on the test about how to name compounds and common names. And I talked about the polyatomic ions. I'm not going to have anything on the naming. And that's it, which is why I don't have a practice problem set. The two things you should know: one, what's the definition of an ionic bond? Two, what's the definition of a covalent bond? And that's really it, okay?
Okay, perfect.
And all questions are good questions in my world. Thank you. All right, with that, it's lab time. And this is going to be real quick because essentially we've already covered this. All right, do you see on your screen, balancing chemical equation lab? Thank you. And for this lab, all you have to do is balance the equations here and on this page 2 and upload it to Blackboard. Now, I've got a little tricky on here. One or two of these might already be balanced, but on a test, if I ask you to balance a chemical equation, you should always be able to do it. Now, one thing that students forget, do you see right here where it says, what is the sum of the coefficients from the balanced form of equation problem 1I, which, or is that L? That's an L. Right here, this one right here, second to last. So you have to balance it and then add up the coefficients. Now, if you look at E, I already used that in the problem set we did, so everybody should get that right. I think I did E. Or did we do, we did C, that was the one we did. So these should all be able to do, and that's the lab. Now, remember my advice. If it's even or odd, like E, you know how do the even odd, and here I'd make each side so it'd be 6 oxygen. I'll let you do that and finish it. Next, if we look at H, I think we did this already, so you better get this one right. Leave hydrogen, oxygen last. Let's find another example like that. I don't see one off the top of my head. But anyways, these are good practice for you, and you need to upload these. Now, what I would recommend is that you get them to me by upload by Friday-ish. Yeah, Friday, today's Tuesday. And that way I can grade it over the weekend. And before you take test number 1, I won't be able to hand back your stuff, but at least you can see, did you do them pretty much correctly? If you got a real low score, you better go back and look at today's videotape. If you got a high score, oh, excuse me, you should feel good and be ready for test number 1, because there's going to be 3 or 4 balanced chemical equations. And with that, I'm done for today. Any questions before I leave? Let me remind you, tonight from 6 to 7:15, I'll have my office hours. If you have any questions whatsoever, stop by, say hello, and I'll help. Also, do the practice problems. Don't wait until Sunday or Monday or Tuesday next week. Start working on them. You should have been doing them already for the chapters, because that way you'll do good on test number 1. And with that, I'm done for today. And I'll say, Gang gesund. Bye now.